Okay, picture this. It's a Tuesday in November, 3 in the morning.
Dead quiet.
Exactly. You're running the entire web infrastructure for a massive hotel chain. And there are like 3 people online looking for a room in Tokyo. The servers are basically asleep.
It's the calm before the storm.
That's the thing. Because you fast forward 2 weeks, holiday booking season kicks off, 9 a.m. sharp, and suddenly it feels like half the world is trying to book a vacation at the exact same time.
The traffic doesn't just climb, it explodes.
And here's the absolute nightmare for anyone in IT. To survive that holiday rush, do you have to pay for that massive peak-level server capacity all year round, even in November?
That is the classic infrastructure trap. I mean, if you provision for the peak, you go broke paying for idle servers most of the year.
But if you provision for the average...
You crash the site in December and just lose all that revenue.
So that's what today's deep dive is all about. We're solving that exact paradox. We've got a pile of technical documentation here on Azure App Service Plans.
The
engine room, yeah. Our mission is to figure out, how do you choose the right hardware? How do you pay only for what you actually use? And this is the part I love. How do you make your app physically breathe with the traffic?
It's funny to say breathe, because in the Azure world, the app service plan really is the lungs. It's all about balancing that performance against your budget.
And it sounds like a lot of people get it wrong.
Oh, for sure. A lot of teams treat it like some static setting you set it once and forget about it.
Right.
Then they wonder why their bill is enormous or their site is crawling.
All right, let's tear it down to the studs then. When I go into the Azure portal and I click Create App Service Plan, what am I actually buying? The name feels a bit abstract.
You are buying a server farm? That is the mental model you have to have.
Okay.
When you create a plan, you haven't even made an app yet.
Yeah.
You're just defining the compute resources, the metal, so to speak.
So like the region, West US or whatever.
Exactly. The region, the operating system, Windows or Linux, and crucially, the size of the virtual machines. How much CPU, how much RAM.
So the plan is the container. It's the hardware. And my actual app is just the code that runs inside of it.
Correct. And that distinction is so important because of how you get billed.
Yeah.
You don't pay per app. You pay for the plan.
Which would imply I can put more than one app into a single plan.
You can, and for a lot of cases you should. Think of the plan like a rental house. You pay the rent whether one person lives there or 5 people live there.
Ah, okay.
So if you have a plan with, say, 5 powerful VMs and you only stick one tiny little app in it, you're just wasting money. You're heating an empty house.
So the strategy is density. You pack as many apps in as you can to get the most bang for your buck.
Up to a point. This is where you get what we call the roommate dynamic.
The noisy neighbor problem. I've heard this one.
That's it, exactly. Because all the apps in a plan are sharing the same hardware. They're all fighting for the same CPU cycles, the same memory.
So if one of my apps decides to process a huge video file or something...
It spikes the CPU to 99%, and the other 4 apps, even if they're totally separate websites, they're all going to slow to a crawl. They effectively starve.
So if I'm designing this, I need to segregate my apps.
You need to be strategic. Group your low-traffic, non-critical apps together in one plan. That's smart. But that hotel booking system, the one that makes all the money, you isolate it. It gets its own app service plan so it has dedicated resources that no one else can touch.
That makes perfect sense. Now, looking at the documentation, there's a very clear... It's like a hierarchy of these plans. It's almost a maturity model for your app.
It's a journey. The docs basically group them into 3 big buckets: shared, dedicated, and isolated.
And most people start in shared, I'm guessing?
Yep, specifically in the free or the shared tiers.
And shared here means I'm not just sharing with my own apps.
Right. In the free and shared tiers, your app is running on a VM that is also hosting apps for totally different Azure customers. You're in a dormitory with strangers, essentially.
Which sounds not great for performance or security.
It's not for production. These tiers have hard CPU quotas. If you use too much, Azure just throttles you.
Right.
There's no uptime guarantee, no SLA. It's for a prototype, a student project, quick dev environment.
Okay, so my prototype is a hit. I want to launch myawesomehotel.com. I can't do that on the free tier.
No. The first thing that forces you to upgrade is usually the custom domain name. To use that, you have to at least move up to the shared tier.
Yeah.
But you're still on shared hardware. The real jump happens when you need that little padlock icon in the browser.
SSL.
SSL and TLS bindings, yeah. To secure the site, And to finally get off that shared hardware, you have to move to the basic tier. That's your entry point to dedicated compute.
And dedicated means the VM is mine. No more strangers.
The VM is all yours.
Yeah.
Well, dedicated to your app service plan, you still share the bigger Azure infrastructure like the network and storage, but the CPU and RAM are yours alone. Basic is fine for, a low-traffic blog.
But not our hotel site during the holiday rush.
No way. For that, you need the industry standard.
Which is conveniently called the standard tier. What's the killer feature there? Why do most production apps land on standard?
Two big reasons. The first one is staging slots. This completely changes how you deploy code.
How so?
Instead of pushing code directly to your live site and, praying it works,
Which we've all done.
we have, you instead push to a staging slot. It's a full copy of your app. You can test it there, hit it with traffic. Then, when you're ready, you click one button and Azure swaps the virtual IP addresses. The staging app becomes the production app instantly, with zero downtime.
That's a huge safety net. But the docs also highlight a second feature in standard that seems like the real game changer, Autoscale.
Yes. Basic tier is all manual scaling. You drag a slider. Standard tier gives you the robot. It lets the infrastructure resize itself automatically based on demand.
And we are definitely going to get into the weeds on Autoscale in a minute. That's the whole breathing concept. But let's finish the ladder. Above standard, there's Premium V2 and V3.
Right. That's when you need raw power. Standard tiers tend to run on slightly older hardware. Premium gets you faster processors and, this is a big one, SSD storage.
So if my app is doing a lot of reading and writing from disk,
It'll feel sluggish on standard. Premium is the fast lane. It also lets you scale out to many more instances, like 30 or more, where standard might cap you out lower.
and then at the very, very top of the mountain, isolated. This looks like it's in a category all by itself.
It is. The isolated tier runs inside something called an app service environment, or an ASE. This isn't just a dedicated VM anymore. This is your app running inside its own dedicated Azure virtual network.
So we're talking banks, government.
Exactly. Workloads that need total network isolation. You can lock it down so it's not even on the public internet, only accessible from your corporate VPN. It's expensive, it's more complex to set up, but you get maximum scale, hundreds of instances, and total control.
Okay, so we've picked our tier. Let's say we're on standard or premium. We want that auto scale capability. Before we turn on the automation, though, the docs make a big distinction between scale up and scale out. They sound similar, but they're not.
Not at all. They're functionally opposite, really. Think of scale up as going vertical. You are changing the size of your individual machine.
I'm trading my sedan for a bus.
Perfect analogy.
Mm-hmm.
You're going from a machine with one CPU core and, 1.7 gigs of RAM to a machine with 4 cores and 14 gigs of RAM. You're scaling up to a more expensive pricing tier.
Does that cause downtime?
Usually, yes, a small amount. Your app has to restart to move to the new hardware, so it's disruptive. You do this when your code just fundamentally needs more memory to even run, or to unlock features that only exist in those higher tiers.
Got it. So scale up is get a bigger machine, which
Yeah.
means scale out must be horizontal.
Scale out is get more machines. You keep the sedan, but now you have a fleet of 20 of them.
That feels more cloud native.
It is. The best analogy I've heard is a grocery store. Scale up is like hiring one cashier who can scan items twice as fast. Scale out is just opening 5 more checkout lanes.
And for a website, more lanes is almost always better.
Almost always. Because you can handle more simultaneous users. If you have 10,000 people hitting your site at once, one super fast computer might still choke.
Yeah.
But 20 medium computers can just divide and conquer.
Right.
And the really beautiful thing about scale out in app service is that your code doesn't have to change. You don't rewrite your app. You just go in the portal, you drag a slider from one instance to 20, and in seconds, the load balancer starts sending traffic to the new machines.
That sounds almost too easy. Just drag a bar, triple my capacity. What's the catch?
There's a massive catch, a huge dependency warning that so many people forget.
Okay.
The app service plan only scales your web server. It does not scale your database.
Ooh, I can see the bottleneck from here.
Right. You scale your web front end out to 50 instances, and they all just start hammering your tiny little SQL database.
The database just melts.
The database becomes the single point of failure. You've essentially built a very expensive, very effective, distributed denial of service attack against your own backend.
So when you plan your web tier scaling, you have to have a plan for your data tier too.
You have to. You have to make sure your database is configured to handle all those new connections, or that it can scale alongside the web tier. It's a critical piece of the puzzle.
Okay, that is a huge takeaway. The compute scales, the data layer is on you.
Correct.
All right, let's get to the holy grail, Autoscale. Because I don't want to be the one waking up at 3 a.m. to manually drag that slider when the traffic hits. I want the system to do it.
This is where we automate the ops team right out of a job. We move from manual scale, which is just a fixed number, to custom auto scale. And you have two main ways to trigger it.
The first is metric-based. This seems like the most common one.
It's reactive. You're telling Azure, hey, watch the average CPU percentage across all my servers.
And if it gets too high, add a server.
Exactly. If the average CPU goes above, say, 70%, add another instance. You can use other metrics too, like memory usage. A really clever one is HTTP queue length.
So if requests start backing up.
If the line gets too long, add a server to clear the backlog. It's a great metric.
Okay, and the second way is time-based. This seems perfect for our hotel scenario.
It's proactive. If you know you're launching a big sale at 8:00 a.m. on Tuesday, you don't wait for the traffic to spike the CPU. Scaling isn't instantaneous. It takes a few minutes for a new VM to spin up.
There's a lag time.
A lag, right. So you set a time-based rule. At 7:55 a.m., scale up to 10 instances. You preheat the oven, then you can have another rule that says at 10 a.m., scale it back down.
Now, you pulled out some golden rules from the docs, because setting this up isn't just checking a box. You can really shoot yourself in the foot.
You can cause a lot of trouble. The first most important rule is scale in is just as important as scale out.
Because of the bill.
Because of the bill. It's so easy to write a rule that says, if CPU is high, add a server. But if you forget to write the corresponding rule that says if CPU is low, remove a server.
You'll scale up during the rush and then just stay there.
Forever. You'll be paying for maximum capacity at 3 in the morning on a Tuesday, so you always need that cleanup rule.
What's rule number 2?
The safety net. Always set your minimum and your maximum instances.
Minimum seems obvious. You don't want to scale down to 0 and turn the site off.
Right. You always want at least 1 or 2 running. But the maximum is what saves your bank account. Let's say you deploy some buggy code, an infinite loop that just eats 100% CPU on every server.
Oh no. The Autoscale engine sees the high CPU and thinks, oh, you're just really busy.
It thinks you're popular, so it adds a server.
Mm-hmm.
The bug immediately eats that CPU too, so it adds another. It's a runaway scale event.
So the max is a circuit breaker.
It's a hard stop. You say never go above 10 instances, and that limits the financial damage from a bug.
Okay, what about this term flapping? That sounded bad.
Flapping is a classic rookie mistake. It happens when your scale-out threshold and your scale-in threshold are too close together.
Give me an example.
Let's say you set it to scale out at 50% CPU and scale in at 45% CPU.
Okay, very close.
Too close. So traffic hits 51%, the system adds a server. Now the load is spread out, so the average CPU drops to like 40%.
Which triggers the scale-in rule. So it removes the server it just added.
And then the remaining servers go right back to 51% load.
So it adds the server back.
Up, down, up, down. That's flapping. It just kills your performance because servers are constantly starting up and shutting down. You need a margin. A good rule of thumb is scale out at 70%, but don't scale back in until it drops to maybe 30%. Give the system room to stabilize.
That's a great specific tip. Now, you highlighted one specific setting that you said was terrifying if you get it wrong, the default instance count.
This is the one everyone just glazes over. When you set up Autoscale, there's a min, a max, and a default.
With the min and max, what is default for?
The default count is what the system falls back to if it loses access to the metrics.
Wait, what? The monitoring can fail?
It's rare, but yeah. The Autoscale engine needs data to make decisions. If that data stream breaks for some reason, if the sensors go blind, it doesn't know if the load is high or low. So it panics and just says, okay, I'm going to set the number of servers to whatever the default is until I get data again.
Okay, let's play this out. My max is up to 20 for the holiday rush, but I left my default at 1.
And the metrics fail right in the middle of that rush. The system will instantly shrink your entire infrastructure down to a single instance.
And the site crashes immediately.
Instantly. But now consider the opposite. You set the default to 20 to be safe.
And the metrics fail at 3 in the morning when no one's online.
Now you're paying for 20 servers for absolutely no reason until someone notices.
So what's the right strategy?
You set the default to a safe number. Maybe what you need for an average business day. Not the max, but definitely not the bare minimum. It's your emergency landing pad.
It's amazing how much is riding on that one little text box.
Which brings us to the last rule. Notifications. Always. Always check the box to send an email or a webhook when a scale event happens.
You just want to know when your infrastructure is changing shape under you.
You don't want your first notification to be the monthly invoice. You want to know in real time, hey, We just scaled out to our maximum. That could mean you're having a great day, or it could mean you have that runaway bug we talked about.
So let's bring it all back. We started with the hotel website. We've learned the app service plan is the billable container, and we can pack apps in there to save money, but we have to watch out for those noisy neighbors.
We walked through the journey of the tiers, from the free shared stuff all the way up to the dedicated production tiers that give you SSL, staging slots, and that all-important autoscale.
And we learned that scaling isn't just one thing. It's a choice between scale up bigger hardware and scale out more hardware. And that auto scale is incredibly powerful, but you need those guardrails.
The scale-in rules, the max limits, a smart default. It's all about aligning the technology with the reality of your business. Your spending can now perfectly match your customer demand, which just wasn't possible a decade ago.
That fluidity is everything. It's the difference between crashing on Black Friday or staying up and saving a fortune on the quiet Tuesday that follows.
Exactly. You're automating the minute-by-minute decisions of an entire operations team.
So here's the final thought we want to leave you with. We talked about that default instance count, the number your system falls back on if the sensors go blind.
It's a small setting, often just a secondary text box that's easy to ignore.
If you're running an Azure app service with Autoscale turned on right now, do you know what that number is set to? If your monitoring failed this very second, does your infrastructure know what safe looks like?
Or would it shrink down to a single server and crash your business? Or maybe expand to the max and burn through your entire budget?
It might be worth taking 30 seconds to log into the portal and just check that one specific setting today.
Definitely a good idea.
Thanks for diving in with us. We'll see you on the next deep dive.